Global IT outage involving CrowdStrike servers. It's impacted everything from businesses to airlines.
July 19, 2024, 4:09 UTC. CrowdStrike, a cybersecurity company trusted by nearly 60% of Fortune 500 companies, pushes a routine software update to millions of Windows computers. Within 78 minutes, 8.5 million devices display the blue screen of death. Airports shut down, hospitals go offline, banking systems freeze, emergency 911 systems fail. Global chaos from 40 kilobytes of code. This wasn't a cyber attack, not ransomware, not a nation-state hacking operation. This was a software bug that slipped through quality control and broke a massive slice of the world's infrastructure. Delta Airlines alone canceled over 5,000 flights. The UK's National Health Service couldn't access patient records. Australia's banking system froze. And the fix? IT teams manually rebooting millions of computers one by one. This is the story of Channel File 291, a single configuration update that triggered the largest IT outage in history, and how one company's mistake became everyone's crisis. Every disaster has a story. Every failure leaves clues. Welcome to Stack Traces, where we investigate what went wrong. CrowdStrike isn't a household name, but their software runs silently on millions of corporate computers worldwide. Their Falcon platform is an endpoint detection system designed to catch hackers, malware, and security threats in real time. Think of it like a security guard that lives deep inside your operating system, watching every program, every file, every network connection. It operates at the kernel level, the deepest layer of Windows, with more privileges than almost any other software. That deep access makes Falcon incredibly powerful for detecting threats. But it also means when something goes wrong at the kernel level, it doesn't just break the security software, it breaks the entire operating system. Instant crash. Falcon updates itself constantly, downloading new threat signatures and configuration files to stay ahead of the latest attacks. These updates happen automatically in the background, sometimes multiple times per day, with no manual approval required. Speed is the priority. On the morning of July 19th, one of those automatic updates was Channel File 291. It was categorized as a rapid response content update designed to protect against newly observed malicious activity, routine, low risk, or so everyone thought. But here's the critical detail that made this failure so catastrophic. Content updates like Channel File 291 were treated differently from full software updates, less testing, faster rollout. And on July 19th, that update was pushed to every single Windows machine running Falcon simultaneously. 4:09 UTC, July 19th. CrowdStrike's update servers begin distributing Channel File 291 globally. Within minutes, the file reaches millions of Windows computers. Falcon sensors download it automatically and immediately begin processing the new configuration. Almost immediately, something goes wrong. Computers running Windows 10 and later versions start displaying blue screens of death. Not just a few isolated machines, thousands, then tens of thousands, then millions. A global wave of crashes. The first reports come from Australia and Asia, where it's already daytime. System administrators arrive at work to find their entire networks dead. Computers boot up, load the Falcon sensor, process Channel File 291, and immediately crash. Then they automatically reboot and crash again. An endless loop. By 4:30 UTC, just 21 minutes after the initial deployment, online forums and social media explode with confused reports. IT professionals share screenshots, error codes, desperately trying to understand what's happening. Is this a cyber attack? As Europe wakes up, the chaos spreads westward. Airports in London, Amsterdam, and Berlin report system failures. Check-in kiosks dead. Flight information displays froze. Manual boarding passes. Long lines of stranded passengers. By 5 o'clock UTC, over 5,000 flights are grounded or canceled worldwide. Hospitals across the UK's National Health Service lose access to patient records and appointment systems. Emergency rooms switch to paper charts. Surgeries are delayed or canceled. Paramedics can't access critical medical histories. Lives are literally on the line. In the United States, as the East Coast starts its workday, emergency 911 call centers go offline in multiple states. Banks report that ATMs and online banking systems are frozen. Retailers can't process credit card transactions. The economic impact is mounting every minute. At CrowdStrike headquarters, engineers are frantically investigating. They see the same thing everyone else sees: massive system crashes correlated with their latest update. At 5:27 UTC, just 78 minutes after the initial deployment, they identify channel file 291 as the culprit and immediately pull it. But pulling the update doesn't fix the problem. The damage is already done. Millions of computers have already downloaded the faulty file. And because those computers are stuck in a boot loop, they can't receive the fix remotely. They're stuck in a loop, essentially soft-bricked. This is when IT teams around the world realize the horrifying truth. There's no automated fix, no magic button. Every single affected machine will need manual intervention. Someone has to physically go to each computer, boot it into safe mode or Windows recovery, navigate to a specific system folder, and delete the corrupted file. For large organizations with thousands of computers spread across multiple locations, this is a logistical nightmare. System administrators spend the next several days working around the clock, going machine by machine. Some companies try remote management tools to automate parts of the process, but many systems are too locked up. Delta Airlines, for example, doesn't fully recover until July 23rd, 4 days later, after canceling more than 5,000 flights and stranding hundreds of thousands of passengers. So what exactly was in channel file 291 that caused this global meltdown? To understand that, we need to dive into what these channel files actually do. CrowdStrike uses them to detect specific types of malicious behavior on Windows systems in real time. Channel file 291 specifically controlled how Falcon evaluated named pipe execution. Named pipes are a Windows feature that lets different programs communicate with each other. Hackers often abuse named pipes to move laterally through networks or execute malicious code, so monitoring them is critical for endpoint security. The July 19th update was intended to improve Falcon's ability to detect newly observed malicious activities involving named pipes, but the configuration file contained a logic error. When Falcon tried to process the instructions in channel file 291, it triggered an out-of-bounds memory read. The sensor tried to access a memory address that was invalid or didn't exist. In most programming languages, an out-of-bounds memory access might cause an error that the software can catch and recover from. But Falcon runs in the kernel mode, where there's no safety net. A memory violation at the kernel level gives Windows no choice but to stop everything to protect the hardware. Immediate system panic. And here's the truly brutal part. This crash happened almost instantly upon boot. Windows loads, starts essential services, loads the Falcon sensor driver. Falcon reads channel file 291, memory error, kernel panic, blue screen. The entire sequence takes just seconds. Because the crash happened so early in the boot process, affected computers couldn't even get to the Windows desktop. They'd boot, crash, automatically reboot, crash again, endlessly. This made remote management impossible. You couldn't SSH in, you couldn't push a fix, you couldn't do anything remotely. Physical access was the only option. One final detail made recovery even harder. The corrupted file had to be deleted from a specific Windows system folder that's normally protected. To access it, technicians had to boot into safe mode or the Windows recovery environment, navigate through protected directories, and manually identify and delete the right file version. In the days following the outage, CrowdStrike CEO George Kurtz appeared on national television to issue a public apology. The company published a detailed root cause analysis, but the damage to their reputation and the trust of their customers was severe. This was supposed to be the company protecting them. The incident exposed a critical gap in CrowdStrike's development process. While full software updates went through rigorous testing and staged rollouts, rapid response content updates like channel file 291 had much lighter validation. The assumption was that configuration files were lower risk than code changes. That assumption was catastrophically wrong. Other security vendors immediately started highlighting their own safeguards. Companies like Black Fog pointed to their use of canary releases, where updates are first deployed to a small subset of customers before wider rollout. That way, if something breaks, it only affects hundreds of systems, not millions. The impact is contained. The economic cost of this outage is estimated in the billions of dollars. Delta Airlines alone lost an estimated $350 to $500 million from flight cancellations and compensation. Hospitals had to reschedule thousands of procedures. Banks lost transaction revenue, and millions of hours of IT labor were spent manually fixing individual machines. But perhaps the most important lesson isn't about testing or stage rollouts. It's about dependency. Nearly 60% of Fortune 500 companies relied on a single security vendor. When that vendor failed, so did a massive portion of global infrastructure. The incident became a wake-up call about the risks of centralization in critical systems. CrowdStrike has since implemented additional safeguards, enhanced testing for content updates, staged rollout capabilities, better validation of configuration files before deployment. But the damage to their reputation persists. Trust in cybersecurity is everything. And on July 19, 2024, that trust was shattered along with 8.5 million computers. The incident raises uncomfortable questions that extend beyond CrowdStrike. How many other critical systems rely on automated updates with insufficient testing? How many other vendors are one logic error away from global disruption? And as our infrastructure becomes more interconnected, are we creating more single points of catastrophic failure? 8.5 million devices, 5,000 canceled flights, billions in economic damage, emergency services offline, all from 40 kilobytes of faulty configuration data pushed in the name of security. The irony is brutal. The tool meant to protect systems became the thing that destroyed them. In the race to move fast and stay ahead of threats, CrowdStrike broke not just things, but trust. And in cybersecurity, trust is the only currency that truly matters. Let me know your thoughts in the comments below. Gravity doesn't negotiate, and code doesn't forgive. Join us next time on Stack Traces as we decode another catastrophe.